Good evening, everyone. Welcome to the Misconceptions in Physics. And it's been a long time that I had started, and I think more than a month, and I have re-initiated this once again. So let us begin with the chapter on rotation. I think only a part of the problems were being done. A few more concepts are left behind, which I observe from the papers. Several of them commit a mistake, and these problems I have taken it once again. So let me finish it as soon as possible and move on to the rest of the chapters. Hope this is useful for your JE or NEET preparations, and these are going on well. Okay, now let us move on. Let me share my screen. And before I start, let me introduce myself. My name is Ratankar Rao. I teach physics in an international school in Bangalore. And my passion is to make videos. And of the late, I got busy with my classes. And as a result of it, I was not able to do anything. Anyway, let us begin. If you want to know more about me or my videos, whatever I have done, more than 200 videos I have crossed so far, you can visit my website, which has been shown over here, which is ratankar.com. I think I'm avoiding it. Okay, fine. It's ratankar.com. So you can go through it, and will be able to access everything. And if you have any questions regarding any numericals in physics, you can always write back to me. My email ID is shown over here. Okay, it is ratankar@gmail.com. And while this is my WhatsApp number, you can always write back to me. You can take a snapshot of the numerical and then put it across. I'd be happy to help you out. All this is just free of service to the student community. Okay, thank you everyone. Now let us begin with the problems on misconceptions in physics. Misconceptions in physics is a set of videos which I have made so far, wherein when I grade the papers of the students, I observe that there are some mistakes which the students make. I just take up those mistakes and resolve those mistakes, understand why they have committed a mistake, where did that misconception came into existence, and thus I am putting it across. Okay, now let us begin with this. Right, currently we are looking at the chapter on rotation, and you can visit my website to know more about all these videos. Now let us start with this problem. The problem here is as such: a kid of mass m standing at the edge of a platform of radius r. This is the 20th problem of radius r, which can be rotated about its axis. So you have a platform like this, a circular platform, and this is my axis of rotation. This is the radius r, and a kid is now standing at the edge of the platform here. And then the mass of the kid is m, and stands at the edge of the platform. It's really rotated. Moment of inertia of the platform is I. Moment of inertia is I. The system is at rest when a friend throws a ball of mass m and the kid catches it. So what you do is a ball is being thrown to the kid, and as a result of it, kid catches this one. The mass of the ball is m. The velocity of the ball is v. Velocity of the ball is v, and at the edge of the platform, it was caught by the kid. Find the angular speed of the platform after the event. So what will happen to the angular speed? Now it rotates like this. So many of them have made a mistake over here by using the conservation of energy formula. So what they have done is half mv square is the energy given by the person, by the friend, to the ball, and as a result of it, the kid receives this energy. And since he receives this energy in turn is made to rotate this what you call the wheel, that is the platform. So as a result of it, half mv square is the input energy, and this is the initial energy, and final energy is nothing but because of this, the platform now starts rotating with an angular velocity I omega square, half I omega square, plus the kid is also standing at this point. It is treated as a point particle. So therefore m r square is nothing but moment of inertia, and omega square, there should be 1 by 2 here. Once again, there are 2 here. Okay, m r square omega square divided by 2 should be the moment of the rotational kinetic energy of the kid. Now solving this, I think I missed something. The answer is correct. Okay, so mv square by 2, 2 goes away here, and thus you get, I take common omega square outside here, and this omega should be equal to m divided by I plus mr square into v. So this v is not inside the root, it is outside the root. Okay, this is what we have, and this is what was the solution given, but this is incorrect. Though the concept of the conservation of energy is applied properly, but still is incorrect. Why is it incorrect? Now let us understand this from the linear motion. Whenever you have a confusion like this, okay, you should understand from linear motion. Now in linear motion, this problem truncates to something like you have an object, you have another object over here. This object comes and hits, and both of them starts moving with a velocity, same velocity. What do you call this as? This is an inelastic collision, right? It's an inelastic collision. Now, in a similar way, here also, when the ball comes and hits this person here, see, you have hands, you hold it across, but definitely you should hold it, right? When you hold it, that means there's some cohesive energy between the ball and the person. Okay, which is energy is exchanged between these two, and then part of it is being given over there. That means you can consider the ball is sticking to the person. Okay, as a result of it, here you observe there is an inelastic collision. Whenever there is an inelastic collision, can we apply COE? Conservation of energy should not be applied, right? So COE should not be applied. So what should you apply then? You should apply conservation of momentum. Now, in this case, we would apply conservation of momentum. This is M, for example. This is capital M. This is moving with U, and this both of them move together. So what do you do here? You write initial momentum is M into U. Final momentum should be equal to M plus M into V. And thus, we write V should be equal to mu divided by M plus M. This is what we get over here. Okay. But here, in a similar way, you cannot apply momentum because, you know, the momentum does not exist over here. You have the angular momentum. This is a rotating platform that we have. So now let us look at the answer. So now, so as a result of it, now the correct solution would be something like this. Now, once again, this is the platform. This is the axis. And this is the velocity of the ball which comes and hits the kid, and the kid catches this, and as a result of it, it is sitting. Okay, it is sitting or standing or whatever it is. Now, as a result of this, applying COAM, conservation of angular momentum. What is the angular momentum of the ball initially of the system before it hits? Li should be equal to M is the mass of the ball, V is the velocity, and R is the distance. MVR is what we get over here. When it hits here, so this is nothing but your R. Let me write this as capital R. Capital R over here. MV into R should now be, now this is Li, and what is LF? Final angular momentum. Final angular momentum tells you that this starts rotating like this, which should be I omega plus this mass. This person is now having a mass capital M, and this ball has a small m, mass of small m. So I will write this as M plus M into, now this is now rotating in this way. Therefore, this also rotates at the same R, omega over here. I can now write this as M R square omega, right? M R square omega, M V R, or V equal to R omega. And thus you can get M R square omega. If you do not understand this, I can write it like this over here. We know that L is equal to MVR. Now V equal to R omega, if I substitute, V equal to R omega. I'm sorry, this should be M R omega into R. This should be M R square omega. See, you get an R square over here. Since the total mass here is M plus M, I have written M plus M over here. And thus, I can now write I plus M into omega. This is your final angular momentum. Now, Li should be equal to LF because angular momentum is conserved. So you get MVR should now be equal to I plus M into omega. I equated these two, thus the value of omega will now be equal to MVR divided by I plus M is nothing but your angular velocity. The angular velocity of the platform after this ball hits the kid is said to be so much. I hope you have understood the solution. So if you really like this video, do share amongst your friends, colleagues, whoever it is needed by. Rotation is a very important chapter from the JE point of view or NEET point of view. And do subscribe to my channel for further updates every day. Okay, one video will be updated. And as much as possible, I would like to upload more number of videos because the forthcoming examinations. Let us see like how many of you fare well. And I hope all success in your life. Thank you everyone for watching this video until the end. And thank you once again. Thank you.